Hey everyone, so I'm going to do the review sheet for your test. Alright, this is test 3. This first question talks about which of the following polynomial has x plus 2 as a factor. What you're going to use here is you're going to institute the remainder theorem, because this is a multiple choice problem, so it's going to be pretty easy if you use the remainder theorem. If you remember, the remainder theorem, what you do is you set this equal to 0 and you get your x value. So x equals -2. And what you will do is plug in -2 into all of these choices and see which choice gets you 0. So for my first example, when I plug in -2, I type it into my calculator, I end up getting 9, and that is not 0. So this is not a factor. X plus 2 would not be a factor. If I plug in -2 to the next one, I would get -2 cubed minus 2 times -2 squared minus 5 times -2 plus 6. Be careful when you type it into your calculator. And when you type this one in your calculator, you do get 0. And that's your answer. Now, I always say check every single choice, so I'm going to do that just to be sure that my choice 2 is correct. I want to plug in -2 here, and I actually end up getting 7, so that doesn't work. And putting in -2 into this one, I get -2 cubed minus 6 times -2 squared plus 11 times -2 minus 6. That ends up getting you -60, so that cannot be the answer. So your final answer is choice 2. Okay, so for this question, you guys need to subtract the two square roots. But to do that, you first need to make them the same radical. Otherwise, you can't combine them. So what I'm going to do is I'm going to simplify each of them and then see in the end if I can combine. So I do 3 over 5, and I'm going to break up 75 into 25 and 3. A to the 4th, I'm going to do power over root. B to the 6th, I'm going to do power over root. And that C is kind of like trapped because you can't do 1 over 2 power over root. I'll just write it there, but it's going to end up going back inside the radical. So I'm going to end up getting 3/5. The square root of 25 becomes 5. The 3 has to stay inside the house because it doesn't simplify. But a to the 4th over 2 gets you a squared. This is multiplied. And then 6 over 2 gets you b to the 3rd. And then that c, like I said, can't reduce, so we're going to keep it inside the radical. Now, what I'm going to do here is I'm going to cancel out the 5's, and I'll be left with 3a squared b cubed square root of 3c. Now I'm going to simplify the next radical. I have a -1/2 already. I'm going to break up 192. That breaks up into 64 and 3. So what I'm going to do is take the square root of 64 to get 8, and then the radical 3 kind of stays. The a to the 4th will reduce just like the other one, and the b to the 6th the same way, and that c is going to be trapped again. These will reduce now to 1 and 4. So I have -4a squared b cubed radical 3c. And if you notice now, the two radicals and the variables after or before the radical are the same, meaning that this is the same as that, and this is the same as that. So that being said, now we can combine our coefficients to get an answer of -a squared b cubed. It's negative because 3 minus 4 is -1, and the square root of 3c. And that's your answer. The next question says 127y cubed plus 125 is factored completely. One of the factors will be. So they want you to figure out one of the factors. So in order to find one of them, I'm just going to factor the whole entire thing. Now this type of factoring is perfect cubes. And the reason why is because I have a cube, 27 is a cube root, and 25 is also a cube root. So what I'm going to do is I'm going to institute the SOAP method. So I'm going to first take the cube root of each piece, and that gets me the cube root of 27 is 3, the cube root of y cubed is y, plus 5. I know I need another binomial. Trinomial. This is a binomial here. I need a trinomial inside here. So I'm going to spell the word SOAP, same, opposite, always, positive. and my signs will now be same as what I started with, so positive, that's positive, and then opposite is negative, and always positive is going to be positive there. To get my first term, I will square my first term. So to get this piece, I'm going to square that. That becomes 9y squared. To get my last piece, this piece here, I'm going to square my last piece there. So I will get 25. And to get my middle piece here, I will multiply 3y times 5, and that is 15y. Now looking at my choices, I notice that my answer is 3y plus 5 because I only want one of the factors. They try to trick you with this choice here, but if you notice, it's positive and not negative because we need a negative here because it's opposite. For the next example, I have a square root equation. So what I'm going to do is I'm going to square both sides. This will cancel out the square root. I'm left with 9x plus 10 equals x squared. Now, you should remember that x squared likes to be positive and equal to 0. On the side that he is now, which is the right side, he is positive. So now I just need to make him equal to 0. And I'm going to do that by subtracting 9x, that cancels, and subtracting 10 to bring it to that side. Now I have 0 equals x squared minus 9x minus 10. Now I'm going to institute the AM method. So x and x. I want opposite signs because I'm multiplying to a negative. The factors of 10 that add to 9 are a negative 10 and a positive 1. I will split this and set each piece equal to 0 and solve for x. That means that I will get x equals negative 1 and add 10 and x equals 10. I will check this in my calculator by putting this into y1 and this into y2, and I find out that the answer of negative 1 does not work, so I will reject him, and my final answer is just 10 because this satisfies the original equation. This is an extraneous solution because it does not satisfy the original. For the next question, I want to solve this radical equation. There's only one radical, therefore I want to make sure the radical is by itself, and it is. In order to solve for this, I need to get rid of the cube root, and to do that, I'm going to cube both sides. Remember, what you do to one side, you got to do the other. That will cancel out the cube root on the left and get 64 on the right. You're going to add 6 to get 5x equals 70 and divide by 5. And you'll get x equals 14. Always check your answers. If you put in 14, you do get the cube root of 5 times 14 is 64, because 5 times 14 is 70, and then minus 6 is 64, and the cube root of 64 is 4, so this does work, and that gets your answer. The next question says, solve algebraically for all values of x. Now this is a typo, it should say n because the letter inside of here is n. This is a single radical equation, so what you do with a single radical equation is you isolate the radical. This is the radical, this whole piece. This needs to move. He's not making the radical happy. So we're going to move him over by adding him. You get the square root of 6n plus 19 equals 2 plus n. Now that the radical is isolated, you can go ahead and square either side. These will cancel. You'll get 6n plus 19. You have to do the box method on this side. I am sorry. It is a binomial, so therefore you must do it, or FOIL. So I have 2 plus n and 2 and n. That gets you 4 and 2n and 2n and n squared. So that'll become n squared. You always want the highest exponent first. These will add to 4n and then plus 4. Bring this down. You get 6n plus 19. Now, like I said in the previous problem, you want n squared in this case positive and equal to 0. On the side that it's at, it is positive, so I'm going to keep it there. But I want to set this equal to 0. So I'm going to subtract 6n and subtract 19. Those cancel and allow you to have the left side equal to 0. So you have n squared minus 2n minus 15. Okay, so now I'm going to institute the AM method. So I will put n and n equal to 0. The factors of 15 that add to negative 2. Well, I want to multiply to a negative 15, so my signs will be different. The factors of 15 that add to 2, well, negative 2 would be a negative 5 and a positive 3. I get n equals negative 3 and n equals positive 5. Now you do have to check your answers to see if you have extraneous solutions. You will plug them into the original. You can use either your calculator or do it by hand. I put this in my calculator by putting the left side into y1 and the right side into y2. And what I found out was that I needed to reject negative 3. He was extraneous. He did not satisfy the original equation, and n equals 5. Okay, so this example is a double radical equation, meaning that there's more than one radical in the problem. Now, when you have more than one radical, you want to make sure they are on opposite sides of the equation. In this case, they are, because here's the equal sign and one radical is here and one radical is there. Now, because they are separated, I can go ahead right away and square either side. On the left side, this will cancel out to get x plus 5, because it's a single radical over the whole entire side. Now the right side, you have to do box method because it is a binomial. There are two pieces. You must multiply them out. So I have 5 minus the square root of x and 5 minus the square root of x. I end up getting 25 and minus 5 square root of x minus 5 square root of x and a positive square root of x squared. I bring this down to get x plus 5 equals. So I'll keep the 25. These are like terms. They'll become a negative 10 square root of x. And the squared and the square root will cancel to get you just plus x. So now your equation becomes a single radical equation. And remember, when you're going with a single radical equation, your goal is to isolate the radical. So I will bring everything away from it to the left side. So I'm going to subtract x. And what happens here is nice because they go away on both sides. And subtract 25. That'll get you a negative 20 on this side equals negative 10 square root of x. Divide by negative 10. Those cancel. You end up getting a positive 2 equals the square root of x. I can square both sides now and get 4 equals just x. I will check my answer into the original question, and this answer does work. It is not extraneous. Okay, so the next question has a squared. You cannot distribute the squared because there is subtraction here. It is a binomial. So because it's a binomial, you have to do box method. You have to. So I'm going to write this out twice and do box method or FOIL, whatever you prefer. So I have 4x minus 3i and 4x minus 3i. I'll end up getting 16x squared and then negative 12xi, another negative 12xi, and a positive 9i squared. These are like terms, so I can combine them. 16x squared is not like, so I'll put them there. I'll get negative 24xi, because those are like, plus 9i squared. Now I squared is negative 1, so I'm going to rewrite this as 16x squared minus 24xi plus 9 times negative 1. That gets me 16x squared minus 24xi minus 9. Nothing else is like, so that's my final answer. Okay, so for this problem they tell you if A equals 4 plus 3i and B equals negative 2 minus 5i and C equals 3 plus 2i, where I is the imaginary unit, they want you to find out A minus CB. So I'm going to write A minus CB, out. They want you to have A minus the product of B and C. So I'm going to write A, 4 plus 3i, minus B, negative 2 minus 5i, and 3 plus 22i is C. So everything's in its place right now. So I have A here, B here, and C here. Now listen, if this was multiple choice, you don't have to show any work. So what I want you to do right now is get the answer by just plugging this into your calculator. You can literally plug this whole thing into your calculator, into your home screen with the exact amount of parentheses. This is helpful for a few reasons. Reason number one being that you get the answer right away, which is 22i. And if you did a bunch of work on your paper on the regions and they don't know really where you went and they see that you have the answer, you might be able to get some points. And also for multiple choice, this will be the answer and you'd be done. But if this was a part two, like how this one is set up right now, you're going to have to demonstrate your work and your steps. So first thing I'm going to do is multiply this with the box method. But I'm going to remember that I have to do 4 plus 3i and then minus and have a distribution over here with the minus sign. So I'm going to do my box method. I'll do that on the side right now. So I have negative 2 minus 5i and 3, 2i. So I get 6 minus 15i, 4i, and minus 10i squared. Now this ends up getting you 6 minus, actually this is a negative 4, because I missed my negative sign here. So negative and negative, much better. Okay, so it'll be negative 6. Minus 4 minus 15 is negative 19i. And then you have minus 10i squared. But we know I squared is negative 1. So that gets end up getting plus 10 minus 19i minus 6. You can add the 10 and the negative 6. And you end up getting 4. So minus 19i plus 4. So I'm going to put that in here. Minus 19i plus 4. And what I'm going to do now is I'm going to distribute that negative. So I ended up getting 4 plus 3i. Negative, negative makes a positive 19i. And then, sorry, this should be going here. To make that a negative 4. And what happens is your 4's cancel out. And you end up adding these guys to get your answer of 22i. Now for this question, it says the expression 6xi to the third times negative 4xi plus 5 is equivalent to. Now, because it's multiple choice, what you could do is pick any number for x. I usually pick 2. And you can plug in x equals 2 into all of these, into your calculator screen with the i's, and you actually end up seeing that this guy matches this result. But if you don't want to do it that way, you can do it out. So you distribute this guy. So 6 times 4 is negative 24. X times x is x squared. I to the third times I is I to the fourth. And then plus 30xi to the third. The only thing left to do is simplify your i's. You can type I to the fourth in your calculator. You end up getting 1. So this is negative 24 x squared plus 30x. You can simplify I to the third in your calculator. Just type it in. And you get negative I. This gets you negative 24x squared, and then negative and the 30 get you negative 30x, and then the I. So your answer is right there. The next question says, what is the quotient of? Now, because this is a quotient and it's multiple choice, what you could do is plug this whole thing into y equals, into y1, and then plug each choice into y2, and then look at your table and see which one matches. If you do that, you find out that this guy matches. Now, if you want to do it the long way, what you can do is synthetic division. And the reason why is because this is a linear term, linear binomial. So what I'm going to do is I'm going to set the bottom equal to 0, and I end up getting what goes into the flower pot, x equals 2. He goes here. Now I'm going to take my coefficients of 1, which is in front of that x cubed, 12, 20, and negative 96. And my first step is to always drop down that first number as 1. Now you're going to multiply 2 times 1 and put 2 here. And you're going to add, so you get 14. And then 2 times 14. That gets you your 28. Add, you end up getting 48. 2 times 48 is 96. You add that, remainder of 0. So I know that this can't be an answer, that can't be an answer, because they have remainders. And the only one that makes sense is this guy, because Remember, you go down by a power. I started with cubed, so this becomes x squared plus 14x plus 48. That's it. So study up, and I'll see you guys tomorrow. So for this question, they want you to algebraically prove or disprove, which means that we want to see if this side equals that side. So what we're going to have to do is deal with the left side because we can actually work with him. And what we're going to do is we are going to write it out 3 times because there's 3 of them. And I'm going to box method or FOIL, whatever you prefer, the first 2. And then once I'm done with that, then I'll box method this guy. So I'll get x squared, xy, xy, and then y squared. And you'll end up getting x squared plus 2xy plus y squared. And then we're going to multiply by x plus y. So I'm going to do another box method. I'll put the smaller one here and then the other guy up here. Okay, so now I'm going to get x to the third, 2x squared y, and then xy squared. Here I'll get x squared y and 2xy squared, and I'll get y to the third here. And I'll combine my like terms. So I'll end up getting x to the third, plus 3x squared y plus 3xy squared plus y cubed. And now what we're going to do is we're going to check if this matches that right side. And if you take a look, this does not equal that. So we disproved it, okay, because it doesn't work. This question asks you to completely factor. The first thing you should always think of is GCF. And there's actually a GCF here. It's 2d. When you take that out, you actually end up getting d cubed plus 3d squared minus 9d minus 27. Now, if you notice, the inside is grouping, so I'm going to split this down the middle because there's 4 terms. And I'm going to take out a d squared here, be left with d plus 3, and take out a negative 9 here because I want to get d plus 3 as well. And then I'm going to have d squared minus 9 and d plus 3. Don't forget about this guy out here because that would really suck. Okay, so now I'm going to do dots here and then bring that guy down. And then that is completely factored. This question says state the end behavior. So if you remember, we have to write as x goes to infinity, y goes to something, and as x goes to negative infinity, so does y goes to something. So look at my ends, which are right here. One's pointing up, one's pointing down. So this is the right side of the graph. So I'm going to look at the first end behavior. So I'm going to put infinity here. And then the other, this is the left side of the graph. It's going down to negative infinity. So that's going to be that. They also want you to state the domain and range. Remember, domain is the x values from left to right. Now, if you notice, this graph will become wider and wider and all the way to the right and all the way to the left. So when I state my domain is all real numbers because it opens up all the way to the right and left. And the same thing with my range. It opens up all the way up and all the way down because of these guys here. So because of that, we're going to also put my range, sorry, not D, my range is all real numbers as well. Remember, you could also write negative infinity to infinity for these guys. That also is the same thing as all reals. You could actually write all real numbers if you'd like. That's how you do that one. Okay, so this one says show all steps to find the product of 2 minus 3i and 5 plus I. Well, product means to multiply, so that's why I have the parentheses there with nothing in between. And then also, you guys could actually get the answer right away if you just plug this into your calculator. But because it's part 2 and because they want you to show all the steps, we're going to have to show our box method or FOIL, whatever you guys prefer. But I know most of you do box, so that's what I'm doing. I'm multiplying these guys, negative 3i squared, and then I'm going to write them in a line. Again, they want to show all steps, so I'm trying to be as thorough as possible. All right, so now I'm going to have 10 minus 13i plus 3, negative 1. Oh, yeah, minus 3, negative 1. Hold on. That's a minus sign. Okay, so now I'm going to do that negative and negative, which makes a positive 3. And then I'll add my like term, which is the 10 and the 3. And I'll get 13 minus 13i is my answer.